All right, so we've got our app downloaded with Jetty Studio onto our transmitter. I'm going to do this video for you on the Jetty transmitter emulator. It's easier to make a video directly off the computer screen like this. So let's assume that we've downloaded the app with the transmitter wizard and the Lua app manager. So we would then go into applications and then down to user applications. And you'll see here I have an app in here loaded up called the sensor emulator, which is a Lua app itself, which emulates a bunch of sensors. So it makes it look to the app that I'm going to run next like it's a transmitter with a bunch of sensors. So it makes it very, very nice for testing. So we'll say add, and then we'll go down and look at my list of applications, of which, of course, there are many here. And we'll pick the instrument panel app, and you'll see it's coming up as version 0.4. And so we go into the instrument panel app. I've already got some panels loaded in here. So let's open up the panels and go ahead and just basically take out all the panels so we can start again from scratch for you. So I start out here with no selected instrument panel. Within any given model, I can have multiple instrument panels, and the instrument panels for each model are remembered separately. So I open up the instrument panels first, and you'll see that panel number 1 is both the selected panel and the home panel, but I don't have any panel defined yet. And so let's go down here. I loaded up all the example panels from the website just to show you. We'll pick the turbine panel, and we'll pick this carbon fiber hexagon. And of course, I can do the plus and the X here to add or subtract panels. Let's just go back and we'll see what this looks like. So if we go back to the top, we've already gone through the step of the displayed telemetry. Well, let's go through that anyway. We go to timers and sensors and displayed telemetry, and you can see here, we'll take out these extraneous ones. You'll see here that, in fact, we'll take this one out to show you how it works. We do a plus, we go to Lua, we go to the instrument panel apps, window 1. We're just going to deal with window 1 for right now. We load that up, we say OK, we go back to the top, and this becomes then our full screen telemetry window number 1. So you'll recognize a lot of what we did here with the RPM and the EGT gauge and the horizontal bar for the fuel remaining, but you'll see that none of this is yet connected to any needles. It's not animated in any way. So let's go ahead and tell the app. We'll go into the instrument panel app. We'll go into inputs, and we'll come down to the fuel remaining, and we'll say, what would we like for gauge 4, which is fuel remaining? What would we like the input source to be? So we can pick a sensor, we can pick one of the controls like a stick or a switch on the transmitter, or we can actually have a mathematical expression with Lua. Let's just stick to sensor right now. And here are the sensors that are being emulated. So I'm going to pick the RPM, have the ability to add custom-built Lua functions. I can have minimum maximum trackers along the edge of the display to show you kind of the high and the low water mark. And then I can edit the minimum maximum value. So let's just say OK to that and go back to the top of my transmitter. Oh, that's interesting. So let's go back and check that again. We must have done something wrong. So inputs, fuel remaining. Oh, I see. We set the tach to the fuel remaining. Okay, so let's do the fuel percentage there. And then let's go to the RPM, and let's actually set that to the RPM gauge. Okay, that will work a lot better. And you'll see that slider number 1 here, which normally be your aileron stick, but it's just a slider for the purposes of this emulator, is emulating the horizontal bar gauge for fuel remaining. So that would normally be a fuel sensor, coming, for example, out of your turbine ECU, or it could be a measurement of milliamp hours from for an electric system that would be the telemetry sensor you'd associate with that. And then slider number 2 is the RPM, and I've got this set to go from 0 to 150, and you can see that when I go past the gauge scale, it's going to flash red to warn me that I'm past the gauge scale. I can actually set that limit if I want lower than the maximum number of the gauge scale, and if I set a lower limit, it'll flash blue if I go below that. So you can see how this slider number 2 animates this gauge. If I go back to instrument panel and inputs, I go back down to my EGT, sensor and I pick the EGT, then you'll see that as I go back to the top here, I've now got, I think that one was number 3. Yeah, it's number 3. So you can see I've got my EGT gauge. So I would proceed the same way. Now, in this particular case, very specifically for the turbine, I've got a window down here. Let's take a look at that. Applications, instrument panel, inputs, and I go to turbine status, and the sensor I want here is whatever the sensor your turbine ECU or ECU adapter provides you that gives you a number that corresponds to the turbine status. In this case, I'm working with a Zcoy Telemetry X adapter on the actual hardware, and I've written some custom Lua code that interprets the codes coming from that telemetry adapter and gives me the correct text for the startup window. And so you'll see here it says trim low, and I've got in my sensor emulator a little sequencer built in, so as I step through the different values here with the SA switch, I'm simulating different readings from the turbine ECU controller. Okay. The other things on this panel, the battery and the pump, look about the same as what you're used to, but if I go to the inputs on the red light, let's do something different on this one. Let's set this one up to be a control. So let's pick a control on the transmitter. Let's use the throttle stick. So I'll move the throttle stick. I will set it to proportional and centered. So I'm getting values from 0 to 100%. I say OK. And the control multiplier, so the control multiplier is gonna present a value to the sensor that's the 0 to 1, of that sensor times this multiplier. So I usually default the multiplier to 100, so it's like 0 to 100%. But in this case, I want to drop that down to 0 to 1 because the max and min value on the light control, we didn't go over it on the website, but was set to 0 to 1. And so when I set one of these little lights to a range of 0 to 1, it's going to switch at half the value of a half. And so you can see that control P4 has been set to control the red light. So if we go back up to the top here and we look at the panel control, you'll see that when I'm above half on the number 4 slider, I'm on, and below it, I'm off. And Harry's done some experimentation hooking this up to a logic switch to indicate that the electric motor was armed, and the red light became kind of a caution light. We have the ability to define that little light to be any of the legal CSS web colors that I can use on our website. So that's a quick overview of what it looks like to basically establish the connection from your sensors to the gauges.